Hey y'all, on this video I'm going to go over one of every type of problem from the study guide on ions and isotopes. Number 1 says how many protons and electrons are in a beryllium atom. So in order to figure this out, I need to find beryllium on the periodic table and look at the atomic number. The atomic number is 4 for beryllium, which means that I have 4 protons. Because this is an atom and not an ion, the positive and negative charges, your protons and electrons, need to have the same number because they need to balance and be a neutral atom, meaning that you need 4 electrons as well. Number 4 says, what is the name of the element whose atom contains 62 protons? Again, 62 protons, the number of protons, is the atomic number. So I'm going to look on the periodic table to find 62 as the atomic number, and that is the name of the element that I'm looking for. So samarium is the answer to number 4. Number 7 says, write the chemical symbol for the ion with 38 protons and 36 electrons. So for this one, I need to figure out what the element is, and then I'll need to write the charge for that ion. 38 protons gives me the atomic number. So find that on the periodic table. 38 is strontium, which is Sr. So I will write Sr for strontium. And then I need to figure out what the charge is going to be. There's a couple ways to do this. The first way would be if you have 38 protons and 36 electrons, that means you lost 2 electrons. Okay, how did I get that? Well, from 38 to 36 would be minus 2, because 38 minus 2 is 36. So I would have to have lost 38. Sorry, I would have had to have lost 2 of my electrons to get from 38 to 36, because if it was neutral, it would have 38 electrons. Okay, so I lost 2, and if I'm losing 2 negative things, remember, if you get rid of negative things, you're becoming more positive. So I would know that this is plus 2. Okay, the other way that you could do that, it might be a little bit simpler for you, is subtract the 2 numbers that you have for protons and electrons. So 38 minus 36 is 2. And then to figure out if it's plus or minus, see if you have more protons or more electrons. If you have more protons, it's going to be positive because protons are positive. If you have more electrons, then your charge would be negative because electrons are negative. If you have more of them, you're going to have a negative charge. For number 10, it says how many protons, neutrons, and electrons are present in this aluminum ion. For these, you need to remember that the number that's at the bottom here is your atomic number. Your atomic number is equal to the number of protons. That's what the atomic number is. So for the number of protons for the first part of this, that would be 13. The next thing I'll figure out is the electrons. You're going to use your charge paired with your protons to figure out the number of electrons. Okay, I should have 13 electrons if this had no charge, but it does. It has a charge of plus 3. In order to get a positive charge, I would have to lose electrons because they have a negative charge. In this case, I know I would have to lose 3 because it's a plus 3. So 13 minus 3 would be 10. Then figure out the number of neutrons. This number up here is the mass number. The mass number is the number of protons, I'm going to abbreviate that here, and neutrons added together. So if you have this number, which is protons and neutrons, and this number, which is just protons, you're going to subtract those to figure out just the neutrons. So 27 minus 13 is 14. For the next problem, it says write the complete chemical symbol for the ion with 80 protons, 122 neutrons, and 80 electrons. So the first thing that I need to do is figure out what the element is that I'm using, and I can do that by going to 80 on the periodic table. Looking for 80, and 80 is right here. That's mercury, which is Hg. So my element symbol is Hg. Remember, down here is your atomic number. Okay, you can look back up here if you need to. Atomic number is 80. This number up top is the number of protons and neutrons. So I'm going to add these two together to get the number that goes right here. And 122 plus 80 is 202. Normally I would write a charge here. However, 80 protons and 80 electrons means that my positive and negative charges are balanced. So this is a neutral atom, meaning it has no charge. Okay, but you can use the charge rules that we did for number 7 that we discussed to figure out what your charge would be if these two numbers were not equal. On the back, we have number 16. I'm going to do part A. It says give the number of protons, electrons, and neutrons for the following atom. This is silver. Remember that this is your atomic number down here, so 47, that's the number of protons. This has no charge, so I know my positive and negative need to be equal. So my number of electrons also needs to be 47. And then for number of neutrons, again, we subtract the mass number minus the atomic number. So 108 minus 47, which is 61. For number 17, it says chlorine has two major isotopes, chlorine 35 and chlorine 37. Part A asks which isotope has the greater mass. These are both written in hyphen notation, meaning this is the element name, a hyphen, and the mass number. So if I have 35 for a mass number and 37 for a mass number, 37 is the larger number, which means that that isotope has a greater mass. So chlorine 37 is the correct answer for part A. Part B says which has more protons. Okay, this is kind of a trick question because chlorine is the element for both of those, and chlorine has an atomic number of 17. It doesn't matter if it's an ion or an isotope, meaning that it would have different number of electrons or different number of neutrons, but chlorine always has to have 17 protons. So for this one, the number of protons would be the same. So which has more protons? Neither, or they have the same. For part C, it says which has more neutrons. An isotope is an atom that has a different number of neutrons, and that's exhibited by the different masses. Because this has a greater mass, it has more neutrons. Okay, that's why it has a greater mass. This one has 2 more neutrons than chlorine 35. Which has more electrons? Again, this goes hand in hand with what I was saying with the number of protons. Neither one of these have a charge, so they have to have the same number of protons and electrons. And because they have the same number of protons, they have to have the same number of electrons. So those are the same. It'll be like that for any set of isotopes that you have. The greater mass and the more neutrons will be your bigger number, and then protons and electrons are the same for both of those isotopes. 18, part A says, give the mass number of each isotope. In order to do this, the mass number, remember, is the number of protons plus the number of neutrons. It's giving me the number of neutrons for that isotope. I just need to figure out the number of protons. Okay, and I would do that by finding this element on the periodic table. Okay, this periodic table is a little bit outdated, but it's 117 here. Okay, this element had not yet been discovered by the time this periodic table was published, But TS, if you look at an updated one, has an atomic number of 117. That's the number of protons, so you add that to the number of neutrons, and 117 plus 117 is 234. That is your mass number. Mass number is the number of protons plus neutrons. For number 19, part A, it says how many protons, electrons, and neutrons are in phosphorus 31? To figure out the number of protons, first I need to go to the periodic table. I can see phosphorus is right here. That's a P. And the atomic number is 15. So that's the number of protons. This does not have a charge. It's just an isotope, meaning that the number of electrons has not changed. And in a neutral atom, your protons and electrons are equal. So this is also 15. And then your number of neutrons you get by mass number minus atomic number. Your mass number is this number after the hyphen, so 31. And your atomic number is what you found out to figure the number of protons. That was 15. Subtract those, and that's your number of neutrons.